You are welcome, my viewers. Olariwaju Bolaniwa is my name. Teaching is my calling. We have here Surds as we are moving on to the intermediate level of Surds. We have the following examples under division of Surds. Before we embark on this journey, I want you to understand something about Surds, which we call to rationalize. Each time we have a denominator with root, we will definitely rationalize it. So, an example of such is each time you have, or let's assume we have a question that results to this, b all over root a. We cannot leave our answer like this, but rather we rationalize it. And how do we rationalize this? The denominator, we use it to multiply the numerator and the denominator. Easy. We just have our b all over root a multiplied by root a all over root a. So what do we have next? B multiplied by root a will be b root a. Then all over root a multiplied by root a is going to be a. Easy. By doing this, we have rationalized the figure we have here to be this. So that is how it is. Now let's go back to the question, which is 5 all over root a. Sorry. Let's go to the first question, which is 5 all over root 5. We simply rationalize this. Let me start from here. If 5 all over root 5, we end up to rationalize this root 5 as numerator and root 5 as denominator. We multiply it that way. So we have root 5 over root 5. So moving further, root 5 multiplied by 5, we have 5 root 5. All over root 5 multiplied by root 5, it will give us 5. We have 5. As this is 5 multiplied by root 5, 5 can cancel 5. 5 here, tapwa, 5 here, tapwa. Your answer will end up to be root 5. You can simply verify this from your calculator. Punch 5 all over root 5. Whatever you get, keep it somewhere and verify it. By the time you press root 5 from your calculator, you have it to be the same value. Easy. So the second one, b. As given here, the square root is all over the numerator and denominator. It is fine to break it to say root 16 all over root 7. It's still the same thing. It's correct. Now, what do we do next? Let's start from the numerator. Root 16 happens to be a perfect square. That's why we are dealing with that first. So, as it is a perfect square, it will be 4 all over root 7. We are not going to leave our answer like this. We need to rationalize it. So, we now rationalize this by saying root 7 all over root 7, which is multiplied by the value we have here. So 4 multiplied by root 7 will give us 4 root 7 all over root 7 multiplied by root 7, we have 7. In this case, here is nothing to be done. Don't make mistake by saying 7 here 1, 7 here 1. That is a wrong notion. 7 cannot cancel root 7. This is your answer for this. So the third one, which is the C, root 10 as the denominator. We can choose to apply the root 10 to multiply the numerator, and the denominator is fine. And you can also choose to first simplify root 10. If you simplify root 10, you still have the same answer. Now let me proceed by simplifying the root 10 first, and see what we'll have. 3 root 2 all over. By the time I break this root 10, it will give me 5 multiplied by 2. So I can break this down. 3 root 2 over root 5 multiplied by root 2. Now you can see that we can cut here. Root 2 can cancel root 2. So by the time root 2 cancels root 2, we shall be left with 3 all over root 5. Now we can rationalize. As we have 3 all over root 5, we say 3 multiplied by root 5 all over root 5 multiplied by root 5. Then we shall have 3 root 5 over root 5 multiplied by root 5. It will give us 5. And if you want to do it the other way around, root 5 multiplied by root 5, it will give us root 25. And root 25 will still be 5. We have our answer here. Now let's do it the other way around. Or we have root 10 as the denominator. I will use it for the numerator and denominator straight away. So we shall have 3 root 2 multiplied by root 10 all over root 10 multiplied by root 10. In this way, I can say this will give us 3 root 2 multiplied by 10. We have 20 all over root 10 multiplied by root 10. We have 10. So we shall now simplify root 20 even further. If we simplify root 20 further, we shall have 3 root. We look for the perfect square. 5 multiplied by 4 will still give us 20 all over 10. So by the time you find the square root of 4, it will give us 2. So the 2 multiplied by 3, we have 6 root 5 all over 10. We will not leave our answer here. There is still one more step. And the step is 2 can go here, 2 can go here. So 2 goes in 6. How many times? 3 root 5 all over 2 in 10 rather will give us 5. This and this. Easy. There are so many ways you can solve this question. So far your step is mathematically acceptable. You will have your answers. From here rather, I can also choose to say 10 cancels 10. So I'll still get the same answer. Let's proceed to the fourth example here. For the D, we have 30 all over root 72. I'll be using a method here because of our time. As my mind places, we have 30 all over root 72. By the time you check root 72 to simplify it, if you look at it logically, 32 multiplied by 2 will give us 72. And 32, sorry, did I mention 32? 36 multiplied by 2 will give us 72. So we shall now say 36 multiplied by 2. 36 multiplied by 2 is still the same thing as 72. Now we break this down because it's a perfect square. 36, root of 36 is 6 all over 2. Root of 36 is 6. Now we are left with root 2, which is root 2 given here because it's not a perfect square. Now the next thing is to rationalize this. The next thing is to rationalize this. But while you are rationalizing, please take note, you are only going to use the one that has root for the numerator and denominator. But before we do that, 3 or 6 can go here and 6 can equally go in 30. So we say 6 goes here, 1, 6 goes here, 5. We have 5 at the top here, then we have root 2 at the denominator position. Now the next thing is to rationalize. We have 5 multiplied by root 2 all over root 2 multiplied by root 2. Then we have 5 root 2 all over root 2 multiplied by root 2. We have 2. In this case, that's all we can, that's how far we can go with this. Easy. We move on to the next one, which is addition and subtraction of surds. So we have these 4 examples for addition and subtraction of surds. Of course, the fourth one is from multiplication and division of surds. So I decided to just add this to it as a kind of a support to what we have already learned. So without wasting time, let's see what this will give us. Now, 175 divided by 25 will give us 7. 25 multiplied by 7 will give us 175. As for this, we will write it as it is, 4 root 7. And the root of 25 is 5. We have 5 root 7. Then we have minus 4 root 7. This is not a multiplication or division sign. It's a subtraction sign. It's telling us that we have root 7 in 5 places. And we have to remove root 7 in 4 places. So all we need to do, or let me just break it down, it's like having root 7 in 5 places. That's root 7, root 7, root 7 again, another root 7, then another root 7. 1, 2, 3, 4, 5. And we have to remove how many root 7? 4. 1, tapwa, 2, tapwa, 3, tapwa, 4, tapwa. How many root 7 do we have left? We have just 1 root 7. We are not going to write 1 root 7, but rather say root 7. Of course, 5 minus 4 will give us 1. Then we have root 7. That's how it is done for addition and subtraction. The second example here, 3 root 28. We now break 28 in such a way that we have a perfect square. We already have our 3. Then we now take it straight. 28. If we decide to break it by 4, we are going to have 7. 4 times 7 will give us 28. Furthermore, we have 63 present here, minus 5, we now check 63. Now for this 63, when you break it by 7, you have 9. 9 multiplied by 7 will give us 63. So we proceed by saying 9 multiplied by 7. And lastly, for this, plus 4. Root 112. Root 112, we proceed by having root 16 multiplied by 7. 16 multiplied by 7 will give us 112. Now, root of 4 is 2. That 2, we multiply it with the 3 outside here, will give us 6 root 7. We have our minus sign. Root 9 is 3. And the 3, you multiply it with this 5, we have 15, still root 7. So this 16 is a perfect square too. Root 16 is 4. 4 multiplied by 4, we have 16, and we are left with root 7. This is well posed again. We have 7, 7, and 7. They are all root 7. So at the moment, I have 6 root 7. I'm owing 15 root 7, and I have 16 root 7 again. It's simple. I'll just assume that, okay, only 15 root 7, and I have 16 root 7. By the time I check and carry out the balancing, I'll definitely be left with a root 7 by applying this and this together. I'm owing 15, I have 16, I have a root 7. So a root 7 along with the 6 root 7 I have here present is going to give me 7 root 7 is, or 6 minus 15, you have minus 9, and minus 9 plus 16, you are left with 7. So the next one, root 3 plus 1 all over root 3 is not rationalized. So the first thing is to rationalize this 1 all over root 3. And doing so, we multiply the numerator by root 3 and we multiply the denominator by root 3. Let me quickly do that. 1 all over root 3 multiplied by root 3 and multiply by root 3. This will give me root 3 all over root 3 multiplied by root 3. I have 3. I have rationalized this in this process. Now for the second one here too, I rationalize by having 1 multiplied by root 27 over root 27 multiplied by root 27 again. This will give me root 27 over 27. But I can still break this root 27 further by saying 9 multiplied by 3. 9 multiplied by 3 will give me 27. Root 9 multiplied by 3 all over 27. So the root of 9 is 3. So 3 root 3 from here all over 27. There is still one more step to take. And the step is 3 goes here, 1, 3 goes here, 9. So we have only root 3 all over 9. What have we done? We have rationalized this. We've rationalized this. Now let's write the question all over because it has been rationalized now. We have root 3. Then the first one we rationalize 1 over root 3, which gave us plus root 3 over 3, and lastly minus 1 over root 27, which is minus root 3 all over 9. This is over 1. As they are in fraction, we carry out a fractional addition and subtraction. We find the LCM of the denominator. The LCM is of course going to be 9. Now 9 multiplied by 1, 9. 9 divided by 1, 9. 9 multiplied by root 3. We have 9 root 3. Our addition sign. 9 divided by 3. We have 3. 3 multiplied by root 3. 3 root 3. Furthermore, 9 divided by 9. We have 1. 1 multiplied by root 3. We have minus root 3. It's getting changed now. Root 3, root 3, root 3. We have 9 plus 3. It's going to give us 12. But there is an invisible 1 here. So the 12 minus that 1 will give us 11. In case you have missed something, we are having 9 root 3. And now to add 3 root 3 to it. So definitely I'm having 12 root 3 by that time. So I'm getting 12 root 3. I'm asked to remove a root 3. So removing a root 3 from 12 of my root 3, I'll be left with 11 root 3. 11 root 3 all over 9. Easy. So the fourth example. Here we have root 3, which we cannot break down. We have root 8 here, which we can break down to 4 multiplied by 2. So let's see what we got here. Root 3 multiplied by 4 multiplied by 2. Then we have root 39. By looking vividly, root 39 cannot be found. Or you cannot break root 39 down in such a way that one will be a perfect square. All we could do here is just to assume it to be 13 multiplied by 3. Because 13 multiplied by 3 will surely end up to be 39. Let's see what we have at the denominator position. We have 24. And as it is 24, by the time we break 24 down, we shall be having 4 multiplied by 6. So this gives us 4 multiplied by 6. Then to 26. By the time you look into the factors, you will see that we don't have any factor that will be a perfect square. So we could just assume or break the root 26 down to 13 multiplied by 2. Now we move ahead. Let's try to break the ones that are perfect square. Root 3 is not a perfect square. Multiplied by root 4 will become 2. Then we are left with the 2 inside of the root, which will be 2 here. For this, we may choose to break the 2 values into different roots, which is root 13 multiplied by root 3. Everything all over, the square root of 4 is going to be 2 root 6. As for these 2, we shall break this into 2, which will give us 13 multiplied by root 2. From here, what do we have? We just break the factors or the values that can be broken. We cut. So we start with root 13. Root 13 here, tapwa. Root 13 here, tapwa. We look again, we have 2. We have root 2 here, and we equally have root 2 here. Tapwa, tapwa. And what else do we have? Nothing at the moment, but rather we can now say root 3 multiplied by root 3. It will give us 3. Not forgetting that we have 2 here. That means we have 2 multiplied by root 3 multiplied by root 3. And root 3 multiplied by root 3 will give us 3. So everything all over 2 root 6. From this, we can say 2 here 1, 2 here 1. We are left with 3 all over root 6. And if you have not forgotten, we can never, under no condition, should you leave your final answer where the denominator is having roots. You will rather rationalize what you have here by saying root 6 all over root 6. 3 root 6 all over root 6 multiplied by root 6. It will give us 6. Then we can now cut once again. 3 here 1, 3 here 2. This gives us the final answer to be root 6 all over 2. Easy. But mind you, students, whenever you are working this, don't ever make mistake by saying 2 here 1, 2 here 3. That one is not acceptable. This is root 6, not just 6. So 2 cannot go in root 6. Thank you so much. In that case, I say thank you so much for your time. And having done this, we shall move to the next content, which will be the advanced level of the surd, where we shall be dealing with conjugate of binomial surd, and we shall also be solving trigonometrical ratio questions, leaving our answers in surd form. And before we embark on that journey, I would like you to work on these 3 tasks given here, and I want you to give your answers at the comment section below. And don't forget to like this video, share with loved ones, and also subscribe to this channel. Can't wait to see you in the advanced level of the Surds. Thank you.